In this lesson, we're going to talk about the Pythagorean Theorem. I've actually taken the notes that I have for this, and I'm going to break it into two different videos. So in this first video, we're just going to focus on calculating a missing side length in a right triangle, and then we'll get to the rest of it in the other video. But to start off, what I'm going to take a look at here is I have a square and a square within a square, and we're going to find the area of all these little pieces. So the first question I have up there is, what's the area of the little square? So I just look at my little square in here and go, if I'm going to calculate the area of the square, I have to do base times height. So the base is c, the height is c, area of that is c squared, to have that one. The next thing I'm going to go to is I got to calculate the area of these little triangles. I'm just going to do one of them. And if we remember back, to calculate the area of a triangle, 1/2 times the base, which I'll call A in this one, times the height, which is B. I can't simplify that anymore, so the area of one of those triangles is 1/2 AB. And then last but not least, I want to calculate the area of the big square. So again, I have to do base times height. Now, the base in this one is that whole length. So I'm going to have to add together the lengths of A and B. That's going to give me the base. Well, the height is the exact same thing. So I'll still have A and B added together. Now, that is a little FOIL problem. So when I FOIL all this together, I'm going to end up with A squared plus AB plus AB plus B squared, which when I put it all together and simplify it, with A squared plus 2AB plus B squared. Now, the reason I did that is because now we have essentially two different ways to calculate the area of this big square. First, the area of the big square in terms of the side lengths, well, that was this piece right here. So if I just clone it, I can bring that right down. But then I have the area of the big square in terms of all the smaller pieces. So when I look at that, the smaller pieces, I have the little square inside, and then I have 4 of those triangles. But we have the area of the little square here. We have the area of the little triangles in all of that. I'm going to bring that down here. So the little square, we said, was c squared. The area of one of those triangles was 1/2 AB. But remember, there's 4 of those. So I'm going to multiply the 4 triangles by 4. So there's the 4 triangles. If I add together the little square, the 4 triangles, I have the area of that big square altogether. But then that's going to be the same thing as the area of the big square when we find it in terms of the sides. Now, the reason I'm doing this is to show you a little formula that's going to be coming up. Now, I'm going to manipulate all this. So it's kind of just a little algebra now. So on this side, right here, 4 times the 1/2 is 2, so I have 2AB plus my c squared here. On this side, we still have our a squared plus 2ab plus b squared. Now, what you notice here is I have 2ab on both sides, so what I'm going to do is I'm just going to subtract it from both sides, and now it's gone. So this left side of my equation now says a squared plus b squared, and the right side says c squared. So what we've just done is we've discovered the Pythagorean Theorem. And what the Pythagorean Theorem allows us to do is it allows us to find missing side lengths in right triangles. Notice your A, B, and C here came from the A, the B, and the C on our little green right triangle. So we can use those numbers to help us find missing sides, which is what I have here on this next slide. The top part here, this is what I refer to as the wordiness of the Pythagorean Theorem. It tells you if a triangle is a right triangle, then the sum of the squares of the measures of the legs equals the square of the measure of the hypotenuse. Again, very wordy. Here's the shortcut version. That's what we just found before. So I like to think of the Pythagorean theorem this way. If you know you have a right triangle, then you can use that little formula to help you find missing sides. So, here we go. Right triangle. I know it's right because of the right angle in the corner. I can use the Pythagorean theorem to help me find those missing sides. So I'm going to start with my A. My A in this case, I'm going to have it be this leg right here. So I just start with x. Pythagorean theorem tells us we have to square it. Plus we have to add on the B. Well, my B is going to be one of the other legs. So in this case it's 12. Oops. I'm kind of a color guy, so I'm going to keep this there. So there's my B. Pythagorean theorem says we have to square that. And then it's going to equal the C, or the hypotenuse, which is right here. But then again, Pythagorean theorem tells us we have to square it. So now we have a little equation. We know how to solve that, so it's just a matter of solving it. So we have x squared plus 144 equal to 169. Subtract the 144 from both sides, so we get the x squared all by itself. And now we have x squared equal to 25. We need to get rid of that square on the x, so we take the square root of both sides. Find out that x equals, remember when you take the square in the equation, you got to look at the positive and the negative answer. However, for this problem, since we're trying to find the length of a missing side, it doesn't really make sense to have a negative answer. So then I don't worry about the negative, and we just know that x equals 5. We always go back and go, is there a label? Which there is in this case. So the answer would be 5 centimeters. And we've calculated it. I have one more example. This one, I've rotated the triangle so it looks a little bit different. Notice in this one we have to find the length of the hypotenuse. So in this one, we'll do the same thing. Our a squared plus b squared equals c squared. I'm going to have the 12 be my a. 12, Pythagorean theorem says square it, add on our b, which would be the 14. We have to square it, and it's then going to equal the hypotenuse, which in the Pythagorean theorem we call it c. It has a variable of y, so I'm going to just stay with what the problem has, and we have our y squared. Now we just solve this equation, just like we did in the last one. This one, I think we'll have one less step because the y is already by itself on that side. So on this one, we now have 144 plus 196. When we add those two together, we end up with 340 equal to our y squared. Take the square root of both sides. We now have y equal to plus or minus the square root of 340. And I'm going to do this two different ways. I'm going to go with the exact, and I'm going to go with the approximate. So for the exact, remember we have to prime factorize 340. So I look at this and go, it's even, so 2 has to be a factor. Well, that'd be 2 times 170. 2 would be a factor of 170, and that would be 2 times 85. And 85 has factors of 5 and 17. So now that that's all done, I look at it and go, well, I have my pair. The square root of that part is just 2. I have these two left, multiply them back together, 85. So technically it's still plus or minus equal to our y, but again, the negative doesn't make sense because we're trying to find the length of the hypotenuse. So my exact value for the hypotenuse is 2 times the square root of 85 would be our y value. Now, if you were trying to find the approximate value, you could just type that onto your calculator. I have done that. When I type this onto my calculator, I get 18.44 for my approximate value of the y value. I rounded that to the nearest hundredth, depending on what you want to round to. That can change. So if you went to just the nearest tenth, it'd be 18.4. So our learning target again was to be able to calculate a missing side in a right triangle, which we have done.